ang noise ay any unwanted form of energy which tends to interfere with proper reception and reproduction of unwanted signal. Ibig sabihin, ang noise ay ang mga hadlang o tinatawag na barriers na pumapasok sa system na nakakagambala sa pagpasok ng mensahe patungo sa mga tatanggap.
Noise effects. Number 1, system performance. It degrades the system performance for both analog and digital system. Number 2, the receiver cannot understand the sender. Number 3, the receiver cannot function as it should be. And number 4, it reduces the efficiency of the communication system.
Merong two types of noises. Ito ang internal noises at external noises. Yung internal noises, ito yung maririnig natin sa ating mga system, and external noises naman yung mga nasa paligid natin. There are two classifications of external noises, which is natural cause and man-made cause. Yung natural cause, ito yung mga natural sound na mag-produce na mga bagay na hindi tayo may gawa, gaya ng lightning, ng sun, radiation, and cosmos. And man-made naman, ito yung mga maririnig natin na gawa ng tao.
Atmospheric noise or static is caused by lightning discharge in the thunderstorm and other electrical disturbance occurring in the atmosphere, while extraterrestrial noise like solar noise and cosmic noise, it both radiates electrical energy in the form of noise over a very wide frequency spectrum, including the spectrum used for radio communication. Man-made noise or industrial noise. By man-made or industrial noise, it is meant as electrical noise such as automobiles, such as motors, or fluorescent lights, or any electrical devices, or any machines that has high sources. Ngayon, let's proceed to problem solving. An amplifier has a bandwidth of 2 MHz with 10K as the input resistor. Calculate the RMS noise voltage at the input to this amplifier if the room temperature is 45 degrees Celsius. Ang ating given sa number 1 ay bandwidth is equals to 2 MHz, resistor is equals to 10K, temperature is equals to 45 degrees Celsius, at ang Boltzmann's constant na 1.38 times 10 raised to negative 23. Ang formula na gagamitin natin ay Vn is equals to square root of 4K dBr. Bago natin i-solve yung problem, ay kuhain muna natin yung absolute temperature in Kelvin, where K is equals to 273 Kelvin plus 45 degrees Celsius is equals to 318 Kelvin. At dahil nakuha na natin yung ating absolute temperature na 318 Kelvin, ay pwede na tayong mag-proceed sa ating problem solving. So Vn is equals to square root of 4 multiplied by 1.38 times 10 raised to negative 23 multiplied by 318 Kelvin multiplied by 2 times 10 raised to 6 multiplied by 10 times 10 raised to 3. Kapag kinalculate natin ito, ang lalabas na sagot ay 18.786 millivolts. And that is our final answer.
Proceed naman tayo sa problem number 2, shot noise. Determine the shot noise current per communication system component having I 35 mA and a signal bandwidth of B equals 60 MHz. Ang ating given na current ay 35 mA at meron din tayong bandwidth na 60 MHz. Shot noise current is equal to square root of 2 multiplied by 1.6 times 10 raised to negative 19 multiplied by 35 times 10 raised to negative 3 and multiplied by 60 times 10 raised to 6 is equal to 8.198 nanoamps. And that's it. That's our final answer.
Problem number 3. Signal to noise ratio. The radio receiver has 50 volts signal voltage at the input and 10 millivolts noise voltage. What is the signal to noise ratio? Ang ating given ay Vs is equal to 50 volts at ang ating Vn is equal to 10 millivolts. Since ang kinukuha natin dito is signal to noise ratio ng voltage, ang gagamitin natin na formula ay S over N is equal to 20 log Vs over Vn. Kuhain muna natin yung value ng Vs over Vn, bali S over N equals Vs over Vn. Bali S over N equals 50 volts over 10 times 10 raised to negative 3 volts. Since milli is equal to negative 3, ang sagot na lalabas ay 5,000. So next step, gagamitin natin yung formula na 20 log Vs over Vn. Bali ang mangyayari ay S over N is equal to 20 log multiply sa sagot na nakuha sa Vs over Vn, which is 5,000 is equals to 73.98 decibels. Tandaan natin na yung 10 log ay ginagamit siya kapag SNR power yung kinukuha natin. While yung 20 log naman ay ginagamit kapag SNR voltage or current yung kinukuha natin.
Problem number 4. Noise figure. The signal power and noise power measured at the input of DCQC amplifier is 170 mW and 1.8 mW. If the signal output 1.5 watts and the noise power is 30 mW, calculate the noise factor and noise figure. So, ang magiban sa problem natin ay PSI or yung signal input, PNI or yung noise input, at PSO or yung signal output, at yung muli is yung PNO, which is yung ating noise output. Unahin natin kuhain yung ating input. PSI over PNI is equal to 170 milliwatts over 1.8 milliwatts is equal to 94.44. Pagkatapos naman ay yung ating output na PSO over PNO. So is equal to 1.5 watts over 3 times 10 raised to negative 3 watts. Again, milli, kaya 10 raised to negative 3. So ang makukuha nating sagot ay 50. Para makuha natin yung ating noise figure, ay divide natin yung ating nakuha input at output na 94.44 sa 50. So 94.44 over 50 is equal to 1.889. So bali yung ating noise figure is 1.889. Para naman makuha natin yung ating noise figure in decibels, ang gagamitin nating formula ay noise figure in decibels is equal to 10 log noise figure. So, noise figure in decibels is equal to 10 log multiplied by noise figure, which is yung 1.889. So, ang lalabas na sagot ay 2.76 decibels.
Last problem para sa ating topic ay ang noise temperature. Determine the noise temperature in degrees Celsius of an amplifier if the noise figure is 5 decibels. Ang ating given ay noise figure of decibels is equal to 5 decibels. Para makuha natin ang noise temperature sa problem na ito ay kukuhain muna natin ang noise figure. Since ang noise figure temperature ay hinahanap natin ay pwede gamitin natin para makuha yung value ay ang antilog of function of dB over 10. I-multiply natin both sides yung 5 decibels at F para makuha natin ang F equal to anti-logarithmic of 5 decibels over 10. So 5 decibels over 10 is equal to 0.5. And F equal to anti-logarithmic of 0.5. Pag kinalculate natin ito ay lalabas ay F is equal to 3.162. Alamin natin kung anong value ng TEQ. With noise temperature ay gagamitin natin ang formula na TEQ or equivalent noise temperature equal to F minus multiply by TO or absolute temperature na 293 Kelvin or 23 degrees. Para makuha yung 23 degrees Celsius ay ima-minus lang natin sa 273 which is yung Kelvin. Then TEQ is equal to 3.162 minus 1 multiply by 20 is equal to 2.162. Then multiply natin sa 20, makukuha natin is 43.24. Ngayon i-check natin kung tama ba ang nakuha natin na 3.162 kanina. Sabi ko nga kanina na ang gagamitin ng formula para ma-check ito ay F is equal to 1 plus TEQ divided by TO. Bale F is equal to 1 plus 43.24 over 20 is equal to 3.162. Ibig sabihin tama yung nakuha natin.
Now, we will give you different problem solving questions for you to solve, and these are the problems.